Hey guys, so today we're going to go over factoring out the GCF, which is the first step of any factoring problem, whether you're factoring quadratic functions with three terms, a difference of perfect squares, sum and difference of cubes, all which will be covered throughout Module 2. The very first step of any factoring problem is just to check if there is a GCF. Sometimes there isn't, but in today's examples, there will be. So we're going to look at number one at the three terms. Again, terms are separated by plus and minus signs. So I'm going to focus on the numbers first. 2, 5, and 10. Is there any common number they can all be divided by? So 2 is a prime number. It can only be divided by 1 and 2. 5 is a prime number. It can only be divided by 1 and 5. So other than 1, we don't even have anything before we can even get to 10. So for the coefficients, the numbers in front of the variables, we don't have a common factor. But if you look at the variables, x to the third power, x to the second power, and x to the first power, so they all have at least an x. So greatest common factor, I can factor x out of this term, which means I can factor it out of each one of these that also have x with them. So if I factor it out, that means I'm going to divide it out of each term. So for instance, 2x to the third. If I factor x to the first out of it, that just means when I divide the like basis, I'm going to subtract the exponents. So 3 minus 1 would give me 2. So x to the second power. If I take 5x squared and I factor out x, meaning I divide x out of that, again, when I divide, I subtract to the exponents. 2 minus 1, always numerator minus denominator, by the way. That'll give me x to the first power. And just keep in mind, if you ever want to just write it out, x squared means x times x. And x to the first power is just one of the x's, so one gets rid of the other, leaving you with just 5x. Either way works. For the last one, 10x, if I divide x out, the x's will just divide out, leaving me with plus 10. So this is the factored form. We factored out the GCF. If ever you want to check, you can distribute the x back in and it should bring you right back up to the line before it. So once you get further into Module 2, you'll learn to factor quadratic functions, which I've already posted as well, and it will be used throughout the rest of the course. But just kind of a fun fact, this can't be factored inside of the parentheses. There are no two numbers that multiply to be 20 and add up to be 5. So just make sure you cover that as well. It's the first video in Module 2. And then we're going to move on to example 2. We're just factoring out the GCF today. So again, I'm going to start off with the numbers. So 5, 25, and 75, what can they all be divided by? Well, again, 5 is a prime number. It can only be divided by 1 and 5. And we don't really count 1 because we don't really write that down outside of x or anything else. So I'm going to check if anything here can be divided by 5. If so, then there's a common factor. 5 can be divided by 5, 25 can be divided by 5, and 75 can be divided by 5. So we found our common factor, which is 5. And just kind of jumping ahead, I'm going to open the parentheses, but we're not quite done yet. So now I'm going to look at a. I have a to the fourth power, a to the second power, and a to the second power as well. So they all three terms have a. The lowest power is a to the second power, so that's going to be my common factor. They can spare at least two a's, because remember, an exponent means how many times it's multiplied by itself. And now I'm going to look at b. B to the third, b to the second, b to the first. They all have b, and now I'm going to take the lowest power then. And I'm going to divide this out of each one of these terms. So if I look at 5a to the fourth power, b to the third power, and I divide it by this colorful GCF I have here, 5a squared b to the first power. The 5 divides out because it's just 1. Remember when we divide, top minus the bottom. 4 minus 2 gives me a to the second power, and then 3 minus 1 gives me b to the second power. And if ever you're confused about if you're doing this correctly, remember afterwards you can always distribute and it should bring you right back up to the line above it. So from here, I'm going to have to make a little bit more room. The second term is negative. Make sure to take the sign with the term. Negative 25 a squared b squared. I kind of wrote over it, but that was the second term. And I'm going to divide my GCF by it to see what happens when I factor it out of the second term. So negative 25 divided by 5 gives me negative 5. Here, if I subtract the powers, 2 minus 2 is 0. Anything to the 0 power is just 1. So again, anything to the 0 power is just 1. It could be 3,555. If it's to the 0 power, it's also still 1. So I'm not going to write that down because negative 5 times 1 is still just going to give me negative 5. So from here, we're going to move on to b. This is b to the second power over b to the first power. Subtracting the powers gives me just b to the first power. Again, I'm not going to write the 1 for the power, so that would just be negative 5b. And final term, I have 75a squared b to the first power. I'm also out of room. 75a squared b to the first power over 5a squared b. So again, I have 75 divided by 5, which would give me positive 15. The 2 minus 2, again, if I subtract the powers for a, that would give me a power of 0, which is just 1. And here, if I subtract the powers for b, 1 minus 1, again, is a 0 power. Anything with a 0 power is just 1. So that's pretty much it. This is my factored form for the GCF in this case. And again, if you ever want to check it, just make sure that you distribute the GCF to each term in the parentheses. And remember, when you multiply, you actually add, when you multiply like bases, you add the exponents. All right, guys, hope this helps.